This is AS2, paper 2 in January 2010, question 3, and this question is on the topic of refraction. Figure 3.1 shows the outline A, B, C, D of a rectangular block made of glass of refractive index 1.46. So we have the glass block here in the diagram. It shows a ray of light incident to the glass block at an angle of incidence of 75 degrees. On side AB, the angle of refraction for this ray is 41.4 degrees, and the refracted ray meets face AD. So it's telling us that it continues on to meet face AD. Calculate the angle of incidence of this ray when it meets face AD. So the first thing we must do is continue the ray on until it meets AD. Okay, and every time we have a ray meeting a boundary, we should always draw a normal, and that normal is at 90 degrees to the boundary surface. Okay, the question then asks us for the angle of incidence of this ray when it meets face AD. So we want this angle in here. Well, if we consider this diagram, we have a right angle triangle at this point. Therefore, the angle of incidence I is 90 minus the 41.4, because we already have 90 degrees here, and the angles of a triangle add up to 180, and when we work that out, it's 48.6 degrees. So 48.6. Using the rules of the angle of the triangle, we have 90 minus the 41.4 gives us 48.6 degrees. Now the question asks us to calculate the critical angle for a ray in this glass meeting the glass air boundary, and the question tells us that the refractive index is 1.46. Well, we know our equation is sine of the critical angle is equal to 1 over the refractive index. So C is equal to the inverse sine of 1 over 1.46 from the question. Having either of these two quoted in your answer gets you the first mark. Then calculating C as 43.2 degrees gets you the second mark. At this point, it is always a good idea to check that your calculator is set up in degrees and not radians. So we use the formula sine of C equals 1 over n, and when we work that out, we get a critical angle of 43.2 degrees. Moving on to the next part of the question then. Part C tells us, using your answers to 1 and 2, deduce what will happen to the ray when it meets face AD. Let's have a look at our answer here. We had the ray meeting face AD at an angle of 48.6 degrees. We also calculated the critical angle to be 43.2 degrees. So the angle of incidence in this question is greater than the critical angle. So we get total internal reflection, TIR for short, but you should write it out in full in the exam. So because that angle of incidence is greater than the critical angle, we experience total internal reflection at that boundary AD. Now, on figure 3.1, so we're going back to our diagram, continue the path of the ray until it has left the glass block. Okay, let's look at this diagram then. What we have is that we have total internal reflection here, and this angle is 48.6, and when we place our protractor on here, we should find that it's 48.6 degrees or 49 degrees. We'll have a slight inaccuracy in this diagram due to the thickness of my marker pen. But then if we come round and mark it out at 49 degrees, Okay, we can join this up. So that's our total internal reflection at AD. But when the ray meets boundary DC, if this is 48.6, then it's going to meet it at 41.4 degrees again, which is less than the critical angle. Therefore, refraction is going to occur. So we need to add in another normal. If we line up our 90-degree line with the boundary of the block, we can draw a normal. And when we have refraction, as it moves out of the glass block, it bends away from the normal. Therefore, if we lay our protractor on, the angle from here to the ray should get bigger. It doesn't have to be exact. So make sure that there's an obvious refraction there. So this refracted angle is greater than the angle of incidence at this boundary. And a diagram is not complete until you put arrows on. What you have drawn are just lines until you place the arrows on it, which makes them rays. So to remind ourselves of this question then in total, we did some work with triangles to work out an angle of incidence. We calculated a critical angle using the refractive index. We then compared the angle of incidence and the critical angle to find that at AD we had total internal reflection, and then we continued the ray until it has left the glass block. So we did that in the diagram, showing that at AD we have total internal reflection, and at DC the angle of incidence is less than the critical angle, therefore we have refraction, and it bends away from the normal as it leaves the glass block. In other words, this angle is bigger than the angle of incidence. So the angle of refraction here is bigger.